Hi VTEPs, this is the Physics in Motion team reporting back for DP2. Today we're going to go over things like our intellectual properties research, as well as our concept generation and selection process, and failure modes and effects analyses for each of our stations. And then we will go over our design for manufacturing, as well as an economic proposal for you guys. So here's a project management status update. As you can see in the Gantt chart here, we've completed all stations through the economic analysis, and we are currently finalizing an integrated prototype with all three stations. And once that is done, we're going to be moving into the prototype testing phase and finalizing our designs. Here, as with this status, we are currently right on schedule, and with that schedule, we will have a 10-day buffer between our finish date and the required project finish date, so that we have 10 days of room for any project delays that we see in the future. Here is our design structure matrix. This can't show our status, but it does clearly show how we work tasks and their relationships to each other. So as you can see, we worked on things like establishment of target specifications and our intellectual properties research in parallel, whereas things like industrial design and design for manufacturing had to be worked on together and finished together.
Before developing product and developing product and making prototype, we thought finding some related patterns is important to develop our product and then prevent infringement. So we researched some patterns related to our product, and these two are, we got some idea from these two patterns for of shape of elevator and pulley for station 1, and from these patterns we got some idea for pendulum part and then shape of station 2. And from original design of station 1, we put elevator to generate more potential energy to show energy conservation.
So here's our failure modes and effects analysis for Station 1. As you can see, our main area of concern is the string and the Arduino DC connection. This is because these two components are the main part of Station 1, and if either of those were to fail, Station 1 would no longer work properly. And so for the string, we're going to make sure to use some good quality, high tensile strength string. That way it won't snap after long amounts of use or possibly slip off. And then for the DC motor and Arduino, we're just going to have to test it many different times to make sure that it works properly under various conditions and try to limit any sort of failure that it can undergo.
From the original design of Station 2, we put some supporters to show clear motion of Station 2, and we also changed the material of pendulum part to reduce the risk of error.
So here's our FMEA for Station 2, the pendulum. The main area of concern we had is with the base and the support structures. That's because if the support structures were to fail, the pendulum would no longer work, and if it were to fail while in use, it could possibly be of harm to the customer. And so that's why we're going to focus on making the supports and the base probably the strongest part of the pendulum itself. That way we reduce the risk of failure, and that way the pendulum itself will work better since it has a stronger base.
From the original design of Station 3, we also put some supporter to show clear motion and accurate motion. And we also reduced the number of balls to reduce risk of failure.
So here's our FMEA for the Newton's Cradle. The main area of concern we had is the wires that hold the ball stationary. This is because the main part of a Newton's Cradle is to transfer momentum through the ball itself. That way it can hit the exit ping pong ball and send it up the exit ramp. And so if these wires were to break over time or slip out of their holding area, the entire Station 3 would no longer work. And so that's why we're going to focus on using strong wire that has limited fatigue, and we're going to make sure that the adhesive material that we use is going to be strong enough for repeated use, and hopefully it'll last for a long time.
So when we were thinking about designing for manufacturing, one of the manufacturing processes we wanted to implement was 3D printing. So we looked through all the features of all three stations of our BRG to evaluate them for which would be the most optimal part to 3D print. And we came up with the rope guide in the elevator portion of Station 1. Because of its very small size, it wouldn't take much material to print. And the design of it would take, it can be printed in an orientation that would minimize support material needed. So once we figured out which part we wanted to use for 3D printing, we used MATLAB code to analyze the different materials that we could use and different orientations that we could print the part in. And we decided that the PLA material would be cheaper and quicker to print. And we decided that the best orientation, after considering 5 different orientations, was going to be 0 degrees, 90 degrees, and 45 degrees with respect to the X, Y, and Z axes, respectively. And you can see the total model material and total support material here were minimized compared to the other orientations that we considered. And that reflected into the time and cost being minimized as well for this part.
So here's our economics proposal for VTEPs. We are going to request a total of $47,000 paid out over the first year. The first 3 quarters are going to be payments of $11,000, and quarter 4 will be $14,000. We plan to begin paying back in quarter 5 of $17,000, and then that's going to increase over the next 3 quarters up to $20,000. And then by year 3, we plan on having more sales revenue along with some lower manufacturing costs, and so that's going to raise our total to $31,000 paid out over 4 quarters for the last year. And so our payback quarter is going to be year 3, quarter 3, and the internal rate of return is 28%. We believe that this is a very attractive rate of return, and that's why VTEPs will accept our proposal. And so then to wrap up the project as a whole, we are finalizing our prototypes and finalizing some other parts of the project, and we plan to have the final report ready to go here within a few weeks. So thank you guys for watching.